So this lesson is about the last integration skill that you have to learn, which is about integrating parametric equation. Now this, I don't know why this not in the textbook. That's why I put it 11.7.5 because you need this before 11.8, but it's not included after 11.7. So I put 11.7.5 integrating parametric equations. Now, before we start, okay, just let's do a quick recap on all the previous integration skills. Okay, so if you remember what I said before, we call it RTSP. Okay, R stands for reverse chain rule. So R stands for reverse chain rule. T stands for trig identities. S stands for substitution. Now with substitution, usually the question will give you what to substitute, so you'll be all right with that. And P stands for by parts. So when do you use by parts? You use it when you have a product. Usually when two terms are of different categories in the isolate rule, then you use by parts. By parts is the formula. I'm not going to go through that. Now in reverse chain rule, when it comes to fraction, okay, I mentioned last lesson about LPP, but now I actually changed my mind. I'm going to use LNP. L stands for ln. So we let y equal ln, the denominator. So ln, denominator. N stands for negative power. So for example, if you have 1 over x plus 2 to squared, then you let y to be x plus 2 to the power of minus 1, because differential power of minus 1 will give you power of minus 2. That's LNP, N stands for negative power. And the last one, which is today, which is partial fractions, which we've covered last lesson. So usually when you see fractions with two factors in denominator, use partial fractions. So this is literally my map of everything about integration, RTSP. But before you do RTSP, obviously, when you see a trigonometry function, let's say cosec cot, first thing you should come to your mind is a formula booklet as well. Remember the formula booklet, there are a wealth of resources, a wealth of expression for you to look at, so make sure you remember that. Before then you can think about RTSP, okay? And then in reverse chain rule, when it comes to fraction, LNP, ln denominator, and then n negative power, p partial fractions. Okay, so let's jump into today's lesson, which is about integrating parametric equation. So suppose we have a set of parametric equation. Hopefully you remember what parametric equation is. It's just a pair of x equation with x and y with a third parameter, which is t. So x is an expression of t and y is another expression of t. To find the area of the curve, we usually want to integrate integral of y dx. The problem is that y is in terms of x. That is not in terms of x. Sorry, in terms of t, not in terms of x. So therefore, we change the formula into integral of y dx becomes integral of y dx over dt. Okay, so there's actually chain rule in there because dt will cancel each other, but you don't have to know that. So what you need is two things. You need the y expression. You also need dx by dt. And also one thing, a new range in terms of t. Okay, so we'll do that. Okay, example: determine the area bound the curve between parametric equation x equals t squared, y equals t plus 1 in x-axis, and the lines x equals 0, x equals 3. So normally, if I want to find the area, I'll need to do the integral from 0 to 3 of the y expression dx. Okay, however, the 3 and 0 are in terms of x, so we need to change that. Okay, so we need to change that. We need to change. So to change, we're going to do a little table value. So x on top and t from 0 to 3. When x is 0, so 0 equals t squared and t equals 0. When x equals 3, 3 equals t squared, t equals square root 3. Now, what about plus and minus? In here, it's just a positive. Okay, so then next thing we need these. So we've got the new range. So we've got a new range in here. What we need is a dx by dt. So we're going to do dx by dt. So let's find dx by dt. So we know x is t squared. So let's differentiate x in respect to t, which is 2t. And then, yeah, so I've got the dx by dt. I've got the y expression, so I can do a substitution. Essentially, it's a substitution. So the area now equals to, now from 0 to 3, now becomes 0 to root 3. So in here, now we're using these two values, 0 and root 3. So we've got the 0 to root 3, okay? So we've replaced the range of the new range, integrating range. Next, when you do the formula, y. So y is t plus 1. Oops. T plus 1. And then times dx by dt, times dx by dt. Dx by dt is 2t, times 2t, and then dt. So that's how we integrate parametrically. So integral of y dx by dt, dt. Okay. Next, we just, to do this, we don't need any LTSP. Do not try to complicate it. You don't have to expand the bracket. 0 root 3, 2t squared plus 2t and dt. When I want to integrate it, I add 1 to the power, divide by the new power, t squared, 0 root 3. If I want to accept value, they can substitute in it, and then you can work out it's 2 root 3 plus 3. So I'm not going to show you how you can do that. 2 root 3 plus 3. Yeah. Okay, so substitute root 3 in there. 2t cubed over 3 plus t squared. So sub in root 3 in it, and then over 3. Yeah. Okay, right, so that's the answer, the first one. Next example, okay. A curve C has parametric equation, x equals t times 1 plus t, y equals 1 over t plus 1 plus t, when t squared is 0. Find the exact area for the region R bounded by C, the x-axis, and the line x equals 0, x equals 2. Now, normally, the area equals 0 to 2 y dx. But we need a new range, so we need to do that. So xt, 0, 2. So when x is 0, substitute into the x equation, 0 equals t times 1 plus t. Now, a silly mistake a lot of students would have made is they substitute x in the wrong place. They substitute x into the t position rather than the x. So you have to be careful. You want to find the t value with respect to x. So this x equals 0. So do not put in the wrong place. Okay, so 0. So we have to do a little quadratic in here. So t equals 0 or t equals minus 1. So which one do you choose? Well, we're told t squared equals 0, so we ignore that. So t equals 0 is the answer. Next one, 2 equals t times 1 plus t. You do have to expand the bracket in here, and then try to solve it. 0 equals t plus t squared plus t minus 2. And then you should get 1 or minus 2. Put in a calculator, you should get t equals 1 or minus 2. Again, you reject the negative number. So there you go. You've got t equals 0 and t equals 1. So we can change the new range into t 0 and 1. What we also need dx by dt. So x equals t times 1 plus t. To differentiate this, you can use product rule if you want to go for the extra difficulty. But why don't you just expand the bracket and differentiate dx by dt 1 plus 2t. Okay, so then the area now becomes equal to, use the formula. Now the new range is from 0 to 1. Okay, just one more thing in here. Now originally it's 0 to 2. Then you put 0. Now, because x is 0, t is 0. So you put the corresponding value in there. Now, even though with this, now there are instances where this could be a bigger number than this one. Now, it's not always the case. We'll put a bigger number on top, okay, when it comes to parametric equation, because we are putting the respective value in there. So when x is 0, t is 0. So put a 0 in there. And then when x is 2, where we'll put a 2 on the top, now we'll put a 1 on top. Now, let's say let's just make up. Let's say t equals 3 in here. Okay, let's say. Then I'll put a 3 underneath in here, because when x is 0, t is 3. Okay, so you could potentially see a smaller number on top and bigger number underneath, which perfectly makes sense. Now, you do want to keep that, because otherwise your answer will be negative, okay, which is not what you need. Okay, you want it to be positive. Yes, as weird as it looks, it will yield a positive answer if the situation comes. I think there might be an example where next one we might have to do that anyway. But yeah, bear that in mind. So next, where are we? So we're going to find y. So remember the formula is y dx by dt. Dt, that's parametric formula. So y is 1 over 1 plus t times dx by dt, which is 1 plus 2t dt. Okay, let me write a bit neater. I'll put the 1 plus 2t on the top over 1 plus t dt. Now, next, I want you to pause the video. I want you to think about, if you want to use a pencil to try it or use a different paper, try it. How to integrate this? Okay, pause the video, think about this. When you're ready, you can press play. So we mentioned about LTSP, didn't we, last time? So in here, let's have a look, okay? So we can do it by elimination. First of all, we definitely know Spaghetti is nothing to do with it. Substitution is nothing to do with it. By parts nothing to do with it because this is division rather than multiplication rather than product. So it leaves us only one trick, which is about reverse chain rule. One technique, reverse chain rule. So one option, reverse chain rule. When it comes to fraction, which we do have in here, we can use ln denominator, the negative power, or the partial fractions. Now, in here, I would like you to think about if I do reverse chain rule. Okay, so if I try ln denominator, remember LNP when it comes to, so let me try to ln the denominator 1 plus t. Okay, then dy by dt, differential ln is 1 over 1 plus t times differential inside is 1, which is 1 over 1 plus t. Is this working? No, because the numerator, you can only balance the coefficient, but you can't balance the variable. There's no t on the top in here. That means we know that y equals ln is incorrect. So L is not an answer. N, negative power. Well, this power is 1. So you can't let y equals to power of 2 either. So if we try let y equals 1 plus t to power of 2, dy by dt, bring the power, differential power, and times the inside is 1, which is 2 times 1 plus t times 1. Again, it's even worse than the first one because not only the 1 plus t is not a numerator. Now, it's not in the denominator. It's in 2 times 1 plus t is in numerator rather than denominator. Also, you don't have the 1 plus 2t either. So again, that's wrong. So the last one is about partial fraction. So, sir, how do you do a partial fraction when there's only one term? Algebraic division. Algebraic division. Okay, so you will have the algebraic division because it's top heavy. So that is the way to go. Okay, so you need to do algebraic division in here. Now with the algebraic division, you might find a bit weird how you put 1, how do you do 1 plus 2t? When you set up algebraic division, do the algebra to put the algebra in front first. So we'll do this. Instead of writing 1 plus 2t, we'll put 2t plus 1. 1 plus t, we'll put t plus 1. Okay. Otherwise, you'll find a bit weird to do that. So t times 2 give you 2t, so 2t plus 2, subtract, that gives me minus 1. So remember that if I do 64 divided by 7, I can do 7 times 9, 63 remain the 1, so 64 over 7 equals to 9 plus 1 over 7. So that's exactly what we can do. Okay, so we can rewrite as 0 to 1, 2 plus minus 1 over t plus 1 dt. The minus 1 looks a bit weird, so I'm going to rewrite a bit neater into 0, 1, 2 minus 1 over t plus 1 dt. Then it makes a lot easier to integrate. To integrate 2 is 2t. To integrate 1 over t plus 1 is ln t plus 1. Right, and then bracket 0 to 1. The question calls for, is 0 to 1? Yep, calls for exact value. So exact value when you substitute in there 1 by 1. So sub in 1, so 2 minus ln 2, subtract, put a bracket, sub 0, 0 minus ln 1, which is all 0. So that's only 2 minus ln 2, and that's the final answer. Let me double check my notes, see if I've got it correct. Yeah, 2 minus ln 2, that's absolutely correct. Okay, right. So last but not least, exam practice. Pause the video, have a go at the question A and B first. Now, let me tell you, A and B has nothing to do with integration. It's 2 marks, 2 marks, 4 marks in here. So pause the video, have a go at the questions for A and B first. When you're ready for the answer for A and B, you can press play. Well, here the answer for Part and Part B. So A is in the y-axis. Y-axis means x equals 0. So you submit x equals 0 and find the value of t. And then once you find the value of t, you submit into y equation, you find the y coordinates. On B, you do the opposite way around. When y equals 0, 0 equals 2 to the power of t minus 1. So 1 equals 2 to the power of t. Now in here, if you're a smarty, you might recognize 2 to the power of 0 is 1. So you could go to t equals 0 straight away from here. Okay, however, if you don't, okay, you get ln on both sides. I'll show you the long way in here just in case. So ln on both sides, bring the t down, divide by over, so you get t equals 0. And then when you find t equals 0, you substitute the x equation, you get b equals 1, 0. So now, okay, pause the video, have a go at part D, just say part C, doesn't matter. Okay, find the area, use the integration, find the exact area. So pause the video, have a go at the question. When you're ready for the answer, you can press play. So the final answer is 15 over ln2 minus 2. All right, if you got it right, well done. That's the end of lesson for you. But if you don't, let's go through step by step. So the final area bounded by the curve. Now I know it's bounded between -1 and 1. So therefore the area is going to be from -1 to 1 of my y dx. But you know, by now you need three things. You need the new range, which we can do first. So x, t, 1, and -1. So when x equals 1, so 1 equals 1 minus a half t. So again, don't substitute the wrong place. You substitute the value of x, not the value of t. So you do that, so you should get t equals 0. And then when you substitute x equals -1 in there, you should get t equals 4. So substitute -1 equals 1 minus a half t equals 2, t equals 4. So this is exactly what I was talking about. Now, when x is 1, t is 0. So you must put 0 on the top. And then when x is -1, t is 4. Therefore, the new range now becomes there's a glitch on the board. So it becomes, now when x is 1, t is 0. So put a 0 on top. When x is -1, t is 4. So we'll put 0, 4. Okay, now, yeah, so if you put 4, 0, you will get a negative answer. You could probably get 2 minus 50 over ln2 if you got it right, which is wrong because you need the opposite around. Because try to put a calculator, 2 minus 50 over ln2, that will give you a negative answer, but area should be positive. Anyway, y. So what's y? Y is 2 to the power of t minus 1. Next, we need to find a dx by dt, which we haven't done yet, so we can do it quickly now. So dx by dt, which is differentiate x with respect to t, differential 1 is 0, minus half t is just minus a half. So times by minus a half dt. Next, minus a half is just a coefficient, a constant. We can put it outside the integral sign. So we stop getting confused. So we can stop us getting confused by that. Next, question is, if you haven't gone up to this step, okay, then, okay, make a correction and try to do that again. And then next, I would like to think about how do we integrate this. Now, 2 to the power of t. We know to integrate -1 is just minus t, but what's the integral of 2 to the power of t? So think about, pause video, think about it, and use your RTSP. When you're ready for the answer, you can press play. Now, do you remember, okay, when I want to differentiate a to the power of x, the integral is ln a times a to the power of x. What it means is, if I differentiate anything with exponential term, the original will still be there. It's like e to the power of something. So what we're doing here is we use reverse chain rule. Okay, so reverse chain rule. So we're gonna let y equals 2 to the power of t. Okay, so like just like e, we try to differentiate, see how it goes. Differentiate it, which is ln2 times 2 to the power of t. So compare this term with the original. Okay, the algebra term matches because it's 2 to the power of t. What it doesn't match is just ln2. So we can balance the coefficient by just dividing it over. So the integral, the overall integral becomes minus a half of 1 over ln2 times the y function 2 to the power of t, and then minus integral 1 is t, and then for 0. That is the integral of 2 to the power of t. Right. Next, then we can substitute 1 by 1. So if we substitute 0 in there, minus a half, you substitute 0, that will be 1 to the power 1 of ln2, 2 to the power of 0. Now 2 to the power of 0 is not 0, so be careful. Do not think, okay, put a 0, cross it out. Minus 0 is gone. Subtract, put a bracket. So 1 over ln2 times 2 to the power of 4 minus 4. Next, minus a half still outside. Next, 1 over ln2, 2 to the power of 0 is 1. So I'm left with 1 over ln2. 0 is gone. 2 to the power of 4 is 16. So minus 16 over ln2. Minus makes a plus, and hence the importance of the bracket, because minus makes a plus, plus, plus. And then 1 minus 16 over ln2, like a fraction. My year 7 would know this, which is minus 15 over ln2, and then plus 4. If I substitute the minus substitute minus a half in there, then I will get a 15 over 2 ln 2 plus minus 2. Oh, apologies. Should be a 2 ln 2. Yeah, sorry, it should be a 2 ln 2 minus 2. Sorry, if you got wrong because there's no 2 in the front, apologies. My mistake, my bad. The final answer should be 15 over 2 ln 2 minus 2. All right. So again, what happened if you put 40 in there? You put 40, you will get the sign will change. Basically, this becomes minus, this becomes a plus, and then we multiply the minus a half in there. These two terms reverse position, and then 2 minus 50 over 2 ln 2 is a negative number, so which is wrong. That's why you have to match the position when you substitute values of t in. Okay, so when x is 1, t is 0, put the 0 on top. Even though 0 is smaller than 4, still fine. Okay, and that's the end. And that's the end of all the integration skill. Next lesson, we're going to look at the area under the curve, which we've done already, to be honest. But we'll look at different types. And then we'll start to apply integration in different contexts, probably trapezium rule, and then maybe about modeling. So, yeah, exciting.